A big problem here. It's one of the harder ones. Hopefully you don't get asked this one. but I can go through the basics with you and kind of show you what they're asking here. So a spaceship is accelerating at 1,000 meters per second. Okay. Here's my fun drawing of a spaceship. So it's accelerating 1,000 meters per second squared. Sorry, meters per second squared. How much force is required from the back thrusters to completely stop the spaceship? Okay. Well, this basically gets into rocket science here. So, the second law, Newton's second law of force is equal to ma, can be stated in terms of momentum. Okay, so momentum, right? P is equal to mv. Okay, and you can say that the force external is the force is equal to the derivative of momentum. Okay, we're in a problem later. We're actually going to derive that, so you'll actually see that. But take my word for it now. Derivative of momentum with respect to time is equal to m times the derivative of velocity with respect to time plus velocity times the derivative of mass with respect to time. Mass times acceleration, derivative of momentum. These are the same units here. Just bear with me on this. dm dt, the change of mass in time, that's what propels spaceships. Okay, that's dm dt, the change in mass over time. It's that loss of mass, it's that pushing the mass over time, which propels rockets. Okay, and in this case, we're going to use it to slow it down. It's the thrust that we're going to use to slow the rocket down. Okay, so for a rocket ship expending fuel at a rate of dm dt, so that's how much mass, how much fuel it's losing, dm dt. The velocity of dm is the relative velocity with respect to m. So v relative is equal to u thrusters minus v rocket. Okay, so the relative velocity is equal to the thrusters, velocity of the thrusters minus velocity of the rocket. All right, what they're saying is that the spaceship is in outer space sufficiently far away from large masses, then the external force due to gravity is negligible. Okay, so basically they're not near some big moon or Earth or something like that where it's going to pull them in. So this is just out there in space somewhere. Okay, the form v rel times dm dt, okay, which is referred to as the thrust, and the force exerted in the spaceship by the expelled gas. So you have here, this is equal to m dv dt. Okay, and basically, here in this case, you're basically, it's kind of like a differential equation. You're basically going to move your derivatives around and solve. So I'm going to put, it's going to end up, once you do your algebra here, dv is going to be equal to u minus v, which is v rel. Okay, is equal to dm all over m. So now I've put like terms on each side. So now, like a differential equation, I can just integrate each side. So I'm just going to integrate. I'm going to integrate over the velocity v0 to 0, because that's what we want to go to 0. And here I'm going to integrate over m0 to m. Okay, that's the final mass. And so here, this is going to be, try to keep enough room here, negative ln of u minus v from v0 to 0, and that's equal to ln of m from m0 to m. And that will basically be the ln u minus v0 over u, if you plug in, is equal to the ln of m0 over m. Okay? So you can basically then just take the exponential of each side to get rid of the ln, so what you're going to come up with is u minus v0 over u is equal to m0 over m. So u is equal to v0. And u, don't forget, is the thrusters. That's how much energy you need, is equal to v0 over velocity you need, minus m0 over m. Okay? And since the final mass m will be less than the initial mass m, the velocity will be negative, okay, which is indicating a reverse thrust. So you've solved for the velocity that you need. I believe that was what they're asking for. How much force is there needed? we use that with our momentum equation. So you can just plug U back into the equation and get your force. So basically, to find the final mass requires knowledge of the time it takes to stop the spaceship from V0, knowledge of the final consumption rate, dm dt. So if you've given certain information, you can get that. So hopefully that makes a little bit more sense than just reading through the study guide. Hopefully I can kind of illustrate that. This is just basic differentials right here, solving differential equations, taking the integrals of each side, solving, knowing your basic operations on natural raw logarithms, and then just doing some algebra to get to U. So hopefully hopefully that helps you out on that problem there. It's a little bit of a tough one. Like I said, hopefully you don't get asked something like that. Definitely something to crack open the book on and go over. That just kind of illustrates how to do it. Okay, moving right along. Next problem.